Okay, we're now going to look at 9b. And 9b is we are firing something upward from the top of a cliff so that it projectile motions down to the ground. So it tells us in the problem that the cliff is equal to a distance or a height called just h. So we're doing this whole problem in variables. We are also firing the object upward with an initial velocity that we're calling v0. And we are firing that at an angle theta. And what we're trying to find is how long it takes to go up and down until it hits the ground in variables. So to do that, I'm going to start by finding my x and y components, but I really don't need the x component, so I'm not going to list that right now, but I do need the y component to find the time it takes to go up. So the y component would be equal to the initial velocity, which is v0 times sine of theta. And then when it goes up to the top of the path, the final velocity would be 0. It's going to be slowed down by a negative g, and I'm trying to find the time to do that. So I'm going to use the first acceleration equation. So I'll write that down. And I'm really using this only in the y direction here. So the final velocity in the y direction is 0. The initial is v0 sine theta minus g times t. And I'm solving for t. So t is going to turn out to be v0 sine theta over g. And I really can't do anything with that other than leave it in variables, but I'll call that the time to go up. So we're just going to store that thought there. All right, the other thing that I need to know is I need to know the additional height that it's going to go up. So I'm just going to call this a d, and I'm going to put that in my list. D equals question mark. And I'm going to use the third acceleration equation to solve for d. So vf squared is vi squared plus 2ad. I'm trying to solve for d. This is a 0. This is going to be v0 sine theta, but I got to square that mess, minus 2g. The negative sign comes from the g, and I'm solving for d. So if we took that negative piece and moved to the other side, we would get 2gd equals v0 sine theta squared. And so to solve for d, we will just divide both sides by 2g. So this is what we end up with, divided by 2g. So that's how high it goes up. And why I need to know that is when I move myself to the right side of my picture over here, I need to know the total height of the cliff. So I'll call that d total. D total equals. So d total is going to be this distance here we just found plus the original height of the cliff. So d total is going to be v0 sine theta squared over 2g. That's how high up it goes, plus the original height of the cliff, which is supposed to be represented by variable h. So I'm just going to store that. All right, so that's how tall the cliff is. To find out how long it takes to fall down, the time it takes to parabola down would be equal to the time it takes to stand at the top of the cliff and just drop something. So that's what we're going to do. We're going to pretend we're dropping something in the y direction. So I'm going to use the PIT, the second acceleration equation. And I'm going to use this just in the y direction. So in the y direction, I'm pretending that the initial velocity is 0. I'm pretending that I'm dropping it from the cliff. So that's going to x out. So this dy is this mess up here, which right now I'm just going to bracket that mess so that we can see what we're talking about. All right, so I'm going to plug in that, but I'm going to do it down here a little bit so we have some more space. All right, so dy is going to be v0 sine theta squared over 2g plus h. And again, we're going to bracket that. And that would equal 1/2 at squared. So equals 1/2, but instead of a, I'm going to plug in a g, t squared. And then I'm going to circle this t because that's actually what I'm solving for. So to find t, I'm going to multiply both sides by a 2. So 2 times the bracket mess. So let's rewrite the bracket mess. Gotta square that over 2g plus h. Alright, so we got rid of the 2 now. But then we would have to divide both sides by g. So we'll just divide by g. And then that would equal t squared. So obviously then t, time, can be represented by this big monster mess of 2 divided by g times v0 sine theta squared. I need to bracket this over 2g plus h. So that's not really pretty, and I could use some common denominators and whatever to, you know, clean it up a teeny bit, but honestly it's not going to get much cleaner than that, and I think I would just leave it just like that.